Right, so with this particular question here, right, we've got the 9 Newton going in the X direction, 12 Newton going in the Y direction, that's great. Now this here, right, they're given an angle of 120, which could maybe put you off a little bit, but if you think about it here, if I just drew this horizontal line in, okay, you could actually work out what that angle is then. That's, you know, if a horizontal line going across there in that X direction, well that's got to be 90 there, isn't it, which means this is 30. So that kind of helps you a little bit with getting that 8 Newton resolved, yeah? Okay, if that makes sense, because the 8 Newton is going at sort of an angle, and it'll have an X component and a Y component. So if that's 90, that's got to be 30. And then when you resolve it, remember now, you can draw triangles if you want, you know, you could even draw one on the shape, and you appreciate now that the adjacent side there is with the angle, isn't it? The adjacent is with the angle, and that will involve cos, won't it? The adjacent, because cos is A over H. So the component here will be 8 cos 30, okay, and then the opposite then side there, okay, opposite the angle, well, opposite is sine, isn't it, yeah, so over H, so that'll be 8 sine 30, and it'll be close to be going that way, okay, it'll be going that way because that's the direction the 8 newtons is pulling in. So it says find the magnitude of the resultant of these 3 forces and the angle between the resultant and the 9 Newton force. So this time it's not in equilibrium. Okay, so we resolve again in the X direction, and what we do is we just assume, we think positive, we assume this is the greater force. Okay, it might not be, but we think of this as positive and that as negative, yeah, because that is the positive direction. So we'll do 9, right, take away 8 cos 30, right? You notice I'm not putting them equals to each other because they're not. Okay, they're not equals to each other because this system is not in equilibrium. If it was in equilibrium and balanced, that would equal that. But it's not, it's moving. So that means there's a resultant force. So to get the resultant force, I see what the difference is between the two. And I take that as positive direction, take away that, and I'll see what I get on my calculator. Okay, so I get my calculator, 9, take away 8 cos 30, and I get out 2.07. Now I'll put a few decimal places, right? 8. I'll go for 4 decimal places there, right? It's good to go for a number of decimal places. Don't cut it short here. We can round at the end. Have a good number of decimal places at the start so that there's no rounding issues later on. Okay, so 4 decimal places in this case was fine. And you notice it's positive, so it is going that way. Okay, it will be going that way. And then let's resolve in the Y direction. So again, we'll be positive. We'll take upwards as positive, so it'll be 12 is positive. Take away the downward force then, which is 8 sine 30. We get the answer out to be 8 exactly. Okay, so that's positive as well. So basically, this system, you're going to have the resultant force going somewhere like this. Okay. It's going to be something like that. That's where the resultant force is going in that direction there, because we've got going back to here, we've got positive 2 in the horizontal direction, but positive 8 in the vertical direction. Okay, so there's more of a pull going in the vertical direction, so it's positive 8. Okay, so that's the sort of angle that maybe we created. That might surprise you because you've got this downward force here pulling at this angle, but you've got these 2 strong forces, haven't you, pulling in the X and Y direction. So overall, when you put these forces together, the whole system is moving in that direction. Okay, so let's work out what the resultant force is, and for that I'm going to draw another diagram. Okay, and I appreciate that, well, okay, we're moving the horizontal that way, okay, 2.0718, and we're going to do vertical this way, 8. Okay, right, so that is the overall effect of these forces, right? So the overall effect is 2.0718 in the X direction, 8 in the Y direction. To get the resultant, as I said, the resultant now is pretty much going to go at that angle, yeah? If we think about it, okay? If it's being pulled in that direction by that force and pulled in this direction by that force, well, overall it's going to be sort of going in that direction, isn't it? Okay, and this angle is going to be quite large, I'd say, because that 8 newtons is going to sort of overcome that 2 newtons, isn't it? It's going to be more powerful. So that angle there, theta, we're going to work out in a minute. Now, to work out the resultant force, we need to think about what's actually going on here. Okay, that resultant force, it sometimes helps to draw another diagram here. That resultant force is created by the 2 newtons of 2.078 going across and the 8 newtons going up, yeah? So 2.0718 that way, and the 8 newtons going up. So you can see now, to get R, right, we've got a triangle, right angle, we know 2 sides, so we can just use Pythagoras, can't we? We know the 2 smaller sides, so we square the 2 smaller sides, okay, and we add them, don't we? And that would give me the square of the other side, yeah? Okay, it would give me R squared, wouldn't it? Yeah? So R squared would equal this squared plus this squared. Now, I don't necessarily need to write R squared there. I can, but I could just go straight for R equals the square root of 2.0718 squared plus 8 squared. Okay, so let's get my calculator. And I get R to be 8.26 newtons. Go for 2 decimal places there, right? The question doesn't say anything, does it? No, two decimal places is fine. Now, to get the angle theta, right, we just got to look to this here, angle theta. And remember, it did say it wanted the angle resultant and direction it made with a 9 Newton force. So the 9 Newton force is that one there. So yeah, it would be right to work out that angle here, okay? That angle theta, and we've literally got the angle they want. So to get that angle theta then, remember we could use SOHCAHTOA, and it's the tan we're going to be using, right, because we've got the opposite and we've got the adjacent. So tan theta equals opposite over adjacent. Okay, opposite's 8, adjacent's that. So that implies then that theta will equal tan to the minus 1, okay, of that. I haven't got much room here, so I'll just do that. But on my calculator, I'll type in tan to the minus 1 of 8 divided by 2.0718. Okay, and I get my answer to be 75.5 degrees, right? So 1 decimal place for an angle. And we're done.